Graph the solution sets for the following inequalities. Then write the solutions using inequalities without absolute value bars. And then we'll demonstrate how to use this mnemonic GoLA to help us come up with those inequalities. So our first absolute value inequality is abs_val x is greater than 4. To locate the solutions on a number line, we'll focus on what happens around positive 4 and negative 4. In other words, we're going to see where the x values are that solve the original absolute value inequality. So if we look at the x value positive 1 and we plug that back into the abs_val inequality, we see that the absolute value of 1 is 1, and that is not greater than 4, so this does not work. So 1 is not part of our solution set. Now looking at negative 1, similarly, the absolute value of negative 1 is also positive 1, and negative 1 doesn't work either. If we were to plug in 0, the absolute value of 0 is 0. That is not greater than 4, so 0 doesn't work. And as a matter of fact, none of the x values that are in between negative 4 and positive 4 are going to have an absolute value that is greater than 4. The values that are going to work are the numbers that are either bigger than positive 4 or less than negative 4. Let's take a look at positive 5. If we throw 5 into the original inequality and look at the absolute value of 5, the absolute value of 5 is positive 5, which is greater than 4, and that does work. Similarly, if we look at negative 5, the absolute value of negative 5 is also positive 5 and also works. What we'll notice is that any x value that is out here beyond the 4s, when we plug these into the original inequality, all of these quantities work. So this is where the solutions lie on the number line, but we're asked to write these solutions using inequalities, where the inequalities that we use do not have absolute value bars. So this region out here is the region where x is greater than 4. This region down here is the region where x is less than negative 4. Now either of these regions work, so we're going to combine these two regions with the word or, meaning that the x values that solve this inequality can either be greater than positive 4 or less than negative 4. Now let's take a look at the other absolute value inequality, and similarly, we'll use a number line to talk about what's happening around our points of interest, positive and negative 4. But this time when we take positive 1 and we plug it back into the original inequality to see if it makes a true statement, we see that the absolute value of 1 is 1, which is less than 4, and now this 1 is part of the solution set. Negative 1 will also be part of the solution set, since the absolute value of negative 1 is also less than 4. 0 is also going to work. The absolute value of 0 is less than 4. The values that don't work this time are the ones that are above the positive 4 or below the negative 4 down here. If we plug in x is equal to positive 5, the absolute value of 5 is 5, which is not less than 4, so 5 is not going to work. Similarly, negative 5 also doesn't work. The absolute value of negative 5 is positive 5, again, not less than 4, so negative 5 doesn't work. And if we were to plug any of the x values that are above the 4 or below the negative 4, none of those quantities make a true statement when plugged back into the original inequality. So again, we're going to write these solution intervals using inequalities without absolute value bars. And this time we have two options for how we're going to do that. One is to say that the x values that solve the original inequality are those that are both at the same time less than positive 4 but also greater than negative 4. So we could use a compound inequality to describe this interval. But in order to introduce this mnemonic that's going to help us to solve absolute value inequalities, let's use two separate inequalities instead of a compound inequality, which means that we would describe this interval by saying that the x values are less than the positive 4, but at the same time, so we use the word and, greater than negative 4. The solutions to this inequality have to be both of these. They have to be greater than negative 4, but also less than positive 4. So now let's try to understand what GoLA means. When we have an absolute value inequality where the absolute value of some variable expression is greater than a positive constant, we'll say that greater than is going to correspond with an or statement. So we'll say O for or. When we have the absolute value of a variable expression that is less than a positive constant, we'll write down an L for less than, and our solution intervals are connected by the word and. So we say A for and. So GoLA is an acronym that can help us to generate these solution intervals that do not contain absolute value bars. Now there's also a pattern for generating the intervals themselves. Notice that one of these inequalities looks exactly the same as the original, except that it doesn't have the absolute value bars. And this is also true down here. One of the intervals in the solution looks just like the original, but without absolute value bars. The other inequality has the same variable side, the direction of the inequality is reversed, and the constant is negated. This is also true here. The other solution interval is described by an inequality that has the same variable side, the direction of the inequality is reversed, and the constant is negated. So we can use GoLA to help us come up with the solution intervals to absolute value inequalities.